Harper. Landon. Addison. Okay, you guys will need a blank piece of paper this morning, and we need to finish up your number 15 notes. So if you please do those two things during the minute of silence, I would appreciate it. Assuming there is a minute of silence.
Susan Townsend.
Yes. Okay, I don't take papers after the assessment,
Oh, okay.
so I can't give you more points for that.
The high school is Thursday, September 12th, 2024. Would you please join me for a minute of silence? Thank you very much. Will you please stand as you are able to allegiance to the flag of the United States of America and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all.
Okay, so last class, after our quiz, we started talking about what a derivative was. So that was your notes on assignment 15, and we just ran out of time there. So let's do the 1 minute review of what we talked about on 15 last class, and then finish that guy up so that we can move on to things beyond the definition of a derivative and what a derivative is. Okay, so on assignment 15, I talked about if you're talking about a linear line, you can either see the slope in the equation or you could count rise over run. But in calculus, we like to look at things with lots of curvature, and we're still interested in slope. We just typically don't call it slope in calculus, we tend to call it derivative. But they basically mean the same thing. And for the next couple of months, that's every time you need to know the derivative of something, you need to ask yourself, what is its slope? Sometimes that's how you get derivative information. So I showed you where the definition of a derivative comes from by taking two generic points, plugging them into the slope formula. We looked at questions 3, 4, and 5, which were very similar work, or I'm sorry, yes, very similar work, but very different looking answers. Typically, your derivative is going to be something with x's in it. It's like a formula that tells you the slope. So question 4, if you wanted to know the slope at 1, you just plug 1 into the derivative, and then you know at that instant what the slope is. And then sometimes they ask you to go even further and make the entire equation of the tangent line. And again, the tangent line is the line that represents the slope at that instant. It shows you, it's like a visual of the slope at that time. So you can get the point by plugging it into the function like you've been doing for years, but the slope is going to come from the derivative. Again, I can't emphasize enough. If you need slope, you need to think about derivative. If you need a derivative, you might need to think about slope. Those two are basically interchangeable. I graphed the function, I graphed the tangent line, and we saw in the calculator that that looked correctly. And then last class at the very end, I talked about you will need to, not yet, and certainly not before tomorrow. Tomorrow is a B day, by the way. But you will need to memorize the standard definition of the derivative and the alternate form so that we can at least do process of elimination questions like this. This is the only way that your AP exam is going to ask about the definition of a derivative. So we practiced 4 of those, and again, I'm going to have you practice a handful more of those in Khan Academy before we get to our next test. But this tends to be a skill that if you practice it now, you probably have to practice it again in a week and a half. Like, it's not that it's that tough, but you get a little rusty. Oh, we did go further in this. Okay, so then given a graph here, we can talk about why the slope doesn't make sense at 4, because there's not even a point there, so how's there a slope there? And there's not a slope at 6. But the main thing I wanted you to see that was consistent about those two is that they are both discontinuous there. Because to be able to take a derivative, it has to be continuous, and that implies 3 other things. So we know the definition of being continuous now, so I don't have to state that so many times. But the other things that have to occur is the slope must exist. Slope must exist. And you'll see what I'm talking about down at the bottom of this page. But sometimes in math classes you've said that slopes are undefined. If it doesn't have a slope, it doesn't have a derivative, because slope and derivative, same idea. And then question 3, or part 3, the visual of this is we say that you can't take a derivative at a cusp. A cusp is like a very sharp turn. We can't really describe the slope there because it's going from something positive to something negative instantly. So, you know, some people might argue it's the positive one, some might argue it's the negative one, some might argue it's the middle, 0 in the middle, but you cannot take a derivative at a cusp. So maybe put that like this. The mathematical way to describe a cusp is the derivative on the left has to be the same as the derivative on the right. Notice this is something positive, this is something negative. You could not take the derivative at this point. So we could say, I don't know, the derivative at A from the left has to equal the derivative of A from the right.
Can we do that, like write it the same as like the limit, like f take A and then minus, like limit?
You would not refer to limits on that part, no.
No, I mean like, but you format it to show that it's coming from the left that way.
Your explanation would be the same, yeah.
Alright.
You'd say to the left it was a slope of 5, to the right it's a slope of -2.
What I was meaning though is, can we write a minus instead of writing from the left?
Like maybe a little negative symbol.
Yeah.
I've never seen it written like that,
Okay.
so I would steer away from that. To be honest, you don't use this very much. You don't use that a lot. This is more common. More common, you have a derivative or a graph in front of you, and you're asked where can you take the derivative or where can you not take the derivative, and a cusp is kind of just visual of it. So up here, I could have also asked right here, at x equals 8, you could not take the derivative. Can't take the derivative at sharp points. It's got to be at nice smooth points. I can take the derivative here because the derivative slope is the same from the left and from the right. At that instant, it's gradually changing. It's not sharp changes. Okay, and then okay, so using this graph, now we can say so differentiability implies that it's continuous, but just because something is continuous doesn't mean that it's differentiable. For what values of x above is the function continuous but not differentiable? That would have been x equals 8. It is continuous at x equals 8, but you couldn't take the derivative there. The 5-second explanation is there's a cusp. The real mathematical explanation is that at x equals 8, the slope or the derivative from the left is not the same as the derivative from the right. Okay, and then finally, using this little graph here, if I asked you what's the slope at point A, I would hope you say that it was undefined. Horizontal lines have a slope of 0. Vertical lines have a slope that is undefined. And if the slope doesn't exist, then the derivative doesn't exist. They're the same thing. If it's an undefined slope, it's an undefined derivative. So if there's a value that's not continuous, you can't take the derivative there. If you have a value that's a cusp, you can't take the derivative there. And the only other way you shouldn't be able to take a derivative is if the slope is undefined, then the derivative is undefined. Okay, you should go ahead and leave this out because you will want to refer to this a bit. Also, one of the 2 handouts you guys picked up, I know we're not getting to it yet. We need to do assignment 16 first. But those book printouts, those are not for you to keep. Again, you're welcome to check out a textbook copy if you want to have it. I did post the digital copy of the textbook yesterday on Google Classroom, so you might just download it one time. But these are just for in-class copies, so I do need these back. Please don't write on the textbook stuff. Sorry, I should have said that sooner, but that way I have a copy for you without you guys lugging a book around. So, but if a handful of people take those each time, then I'll have to stop doing that because I can't make that many copies for something that we don't have to make copies for. Okay, so now, last class we talked about, and this really goes back to the daily meme here, we talked about the definition of derivative, which is kind of messy. Hopefully you have an idea of where it comes from, but we are going to take thousands of derivatives this year, and you don't want to have to do it by the definition every time. It's long, tedious, and usually unnecessary, or almost always unnecessary. For this class, it will always be unnecessary. So it's just basically saying, like, generally people are not happy about seeing this, but this means the same thing. Remember, one little tick mark means derivative. This is just a definition of derivative. So on assignment 16, I'm going to show you some of the shortcuts so that we can avoid the definition of a derivative. But eventually you'll need to memorize that definition of a derivative. Notice sometimes they do delta x, which it just means to change in x. And then sometimes we say h, but those mean the same thing. So if that bugs you, you just put a h where there's a delta x. Okay, so most of this stuff on here is me just basically telling you what the properties are. I'm going to try to give you some examples to help you see why it is what it is. but these are the things that you will want to memorize. And in fact, it'll be pretty much impossible not to memorize them. But the sooner you memorize them, the sooner class will, or the smoother class will go. Okay, so if I asked you, what is the derivative of y equals 6? That would be a horizontal line. Y equals the number is a horizontal line. And what is the slope of a horizontal line?
0.
So then what's the derivative of a horizontal line? 0. Same thing. Slope and derivative mean the same thing. So this property says if you take the derivative of a constant, it's going to be 0. Because a constant's flat. It's not changing. Derivative is about change. How fast or slow something's going up or down. So over here, if I said this notation just says take the derivative. Take the derivative of -2. Well, the derivative of constant is 0. So if you know that, it's half a second of work. Okay, probably the biggest one, and I'd actually be surprised if a few of you haven't heard of the power rule before, but the power rule is probably going to be our most used calculus thing, period, not just derivatives. But the power rule says if you want to take the derivative of x to some n power, that's the same as n times x to the n minus 1. So it's a lot easier than it sounds. Basically, you're going to take the exponent n and bring it down out front. That's why there's an n here. And then after you bring it down out front, you're going to lower the exponent by 1. N changes to n minus 1. So the derivative of x squared, you would bring the power down and then lower the power by 1. The derivative of x squared is 2x. Now again, you could do x squared into the definition. You could do f of x plus h minus f of x all over h, and then take the limit as h approaches 0, and you would also get 2x. But this is so common and so easy that we just do it anyway. So again, x to the 8th, bring the 8 down, and then lower the power by 1. The derivative of x to the 8th is 8x to the 7th. X to the 5th, bring the power down, lower the power by 1. That is called the power rule. And even if it's something ridiculous like x to the 1,000th, you would just bring the 1,000 down and then lower the power by 1. Power rule, very, very easy to use, assuming it's set up correctly. Okay, and then the next step is this one works like limits did. This is called the constant multiple rule. So if you want the derivative of a number times a function, that's the same as the number times the derivative of the function. So you don't have to write this both ways on every question, but I do want you to do it just on this one, please. You could think of this in two different ways. You could either say, I'll deal with the 2 later, and I'll take the derivative of x squared, bring the power down, lower the power by 1, and then reduce. And honestly, a lot of times that's the way that makes sense. The 2, again, if you're taking the derivative of a constant times a function, just pull the constant out and deal with it later, like I did right here. 2, I pulled it out and dealt with it at the end. But to be fair on this question type, you really could just do power rule. When you bring this power down, you bring down the 2. If there's something already there, multiply those together and then lower the power by 1. Either way. So you could deal with the 3 at the end, take the derivative of x to the 8th, and then just multiply those together. It's basically 3 times bigger than the derivative of x to the 8th because you've got it times 3. This one's going to be 1/2 times the derivative of x to the 5th. So bring the power down, lower the power by 1. Bring the power down. There's already a 4 there, multiply it by the 4, lower the power by 1. But I'm just telling you that if there's a constant there, feel free to pull it out front and deal with it later. We did the same thing with limits. If you did the limit as x approached something of 2 f of x, we could just do the limit of f of x and then multiply our answer by 2. Derivatives work the same way for that. Derivatives also work the same way for adding and subtracting, meaning that they are fairly intuitive to people. If you wanted to know the derivative of something plus something, you could just take the derivative of the first, take the derivative of the second, and since it said plus, you're going to add them together. And if it's minus, you can take the derivative separately and then slap a minus sign in between them, just like we did with limits. So this is good because it doesn't really matter if it's got one term or a bunch of terms. We can probably apply the power rule multiple times. So the power rule here would be 4x plus the power rule here would be 24x to the 7th. So again, compared to using the definition, you'd just be crazy to use the definition there if you didn't have to. That's the full derivative. And again, remember what this means. This is like a formula for slope. So if I cared about the instantaneous rate of change slash slope slash derivative at a certain value, I would just plug that value into the derivative and I know the slope of this line. So if it's got a minus sign, same idea. Do this one separately. Do this one separately. Now this part, this might look a little funny at first, but if you think of this as y equals mx plus b, the slope is obviously 7, slope is derivative. You can also do power rule. When you bring the power down, 7 times 1 is 7, and then you lower the power by 1, it becomes 0, and what would x to the 0 be? Right, because anything to the 0 power is 1. It had a minus sign in between, so just slap a minus sign in between. Add and subtract work intuitively, just like limit, add, and subtract worked intuitively. Unfortunately, multiply and divide won't. That is what we'll be looking at tomorrow. When you want the derivative of something divided by something, or the derivative of a function times another function, we have to have special rules for those. But that's for tomorrow. Okay, I would like you to try this one, please. Try to take the derivative of all 4 of those terms just to make sure that you are registering that correctly. Okay, trying to be patient there, but again, you're just doing the same thing over and over. So power rule here, bring down the 5, lower the power by 1. There was already 2 there, then the 2 gets multiplied by the 5. Power rule, power rule, power rule. Make sure all of that looks good. Any questions about that piece? Okay, then some of the others. So basically I've shown you power rule, practice it a few times, but the only rule I've shown you other than power rule is that the derivative of constant is 0. So some of the others you will need to memorize is all 6 of the trig functions. So the derivative of sine, derivative of cosine, derivative of tangent, derivative of secant, derivative of cosecant. You will have to know all 6 of those. But I won't even show you the other 4 until tomorrow. But the derivative of sine and cosine come up all the time. So I need to show you that one immediately. The derivative of sine is cosine, but the derivative of cosine is negative sine. So taking the derivative of one of them just changes to the other, and the derivative of the other one changes to the other times the negative. You need to make sure that you get that straightened out in your brain. So anytime you need the derivative of cosine, it's going to be negative sine. Anytime you want to take the derivative of sine, it's going to be cosine. And then if there's more than one term, just like we did on the other side of your notes, you just do them separately. Derivative of cosine is this. Derivative of sine is that. And then it's got a minus sign in between. Once you memorize those, that's a 1 second question. Okay, and then also pulling from some of the other stuff I talked about, remember this 3. Do you want the derivative of 3 times something? You can pull the 3 out front and then just do the derivative of the trig function. And then same thing over here. The derivative of negative 4 cosine x is the same thing as negative 4 times the derivative of cosine, which is negative sine. So that negative makes that minus a plus. This one's just going to be 3 times bigger than whatever the derivative is. This is negative 4 times whatever the derivative is. So derivative of the sine is cosine. The derivative of cosine is negative sine. We will memorize those. Okay, the easiest one is the derivative of e to the x. It is one of very, very, very few functions that is his own derivative. E to the x grows at the rate of e to the x. So you're going to see this lots and lots and lots and lots. Derivative of e to the x is e to the x. If you want it to be 5 times bigger, it's going to be 5 times bigger than e to the x. If you have multiple terms, just do them separately. There's a minus sign in the middle, so slap a minus sign in the middle. There's not much there. Derivative of e to the x is e to the x. Yeah.
Can't you combine like terms for that also?
Oh, sure. Yeah, you could. Now, I'm not going to focus too much today on simplifying, but that's probably going to be the biggest headache for you guys tomorrow, is some of the simplifying, and some questions take a lot of work. So, okay, so let's kind of build upon what we've got here. The derivative of the constant is 0. We've got the power rule. If it's the derivative of a number times a function, just take the derivative of the function and multiply it by the number. If you're just adding or subtracting, you can do those individually and then slap an add or subtract sign. Derivative of sine is cosine, the derivative of cosine is negative sine, and the derivative of e to the x is e to the x. Okay, and then the last two I'm going to show you today. There is a couple others, but these are the ones that you kind of have to know to get your feet off the ground. The derivative of natural log of x is one that shows up a lot in calculus, and it becomes 1 over x. And when we do logarithms in calculus, 99% of the time we just do natural logs. We don't use logs with the other bases very often. So when you need the derivative of natural log of x, it's 1 over x. This would be 2 times bigger of 1 over x or 2 over x. And this one is kind of the mixed bag. It's throwing several different things at you that I've said on this worksheet. So I want you to try this one. Try all 3 of those terms. And try to do it without looking at your notes. Just write down what you think. You can correct it if need be. Okay, so for this part, you should have got 2 times 1 over x. For this part, you should have got negative 4 times the derivative of e to the x. And for this part, you should have gotten 8 times the derivative of cosine, which was what? Good, not sine, but negative sine. Make sure you have a minus sign there, not a plus sign. Okay, and then this one, honestly, I'm not sure why I put this on here. We almost never use this, but I guess we can just fill it out for your notes real quick. If you wanted to take the derivative of a log that wasn't a natural log, it just fits this pattern. So log of what you're taking goes in the denominator, taking the log of x. And then also in the denominator, you need the natural log of whatever the base was. So natural log of 3 in this case. Technically, that's the same for natural log. It's just we don't do the natural log of e because that turns into a 1 anyway. So 1 over what you're taking the log of, and also 1 over the natural log of the base. Okay, so again, this one, I'm just trying to show you that it's really not that different than the natural log one. But this, you could do 1 over x times the natural log of the base. But what is the natural log of e?
1.
And this really just means natural log of x, right? Log base e is natural log. So that's why it comes out to be that way. We just don't memorize this part when we talk about that. Okay, and then this would be 1 over x times 1 over natural log of 9. Again, those aren't real important right now. We'll brush past those. But it's good for you to have it in your notes, I guess. Okay, so one of the biggest challenges today and a bit tomorrow is you need to understand that the power rule, as easy as it is, the questions have to be written in a certain way. So right now, this question is not set up to do the power rule. You can't just do the power rule of the numerator and denominator and then divide them. That works with limits, that doesn't work with derivatives. What you're going to have to do is you're going to have to use your algebra skills. That could be exponents or fractions or trig identities or anything, but you need to make this look a certain way. So instead of calling this 1 over x to the positive 2, I'm going to call it x to the negative 2, because now that it's in the correct format, I can do power rule. I can bring the power down, lower the power by 1, and then the only other thing you're going to have to get in the habit of doing is negative exponents are typically considered unsimplified in math. So I move this up to the numerator so that I could use the power rule, but in the end, if I have a negative exponent, I need to move it back down. You shouldn't have any negative exponents in your answer. So it was still the power rule, but this is not in the power rule format, so I had to rewrite it with exponent rule so I can use the power rule. Okay, and the next two questions will be similar. I would like to use the power rule on this, but it doesn't look right yet. So what you can say is, well, the 5th root of x is really just x to the 1/5. Now it looks correct. Now it's in the right format that power rule expects. So I can bring the power down, lower the power by 1, and don't leave your answers with negative exponents. If it has a negative 4/5 exponent in the numerator, that's the same as having a positive 4/5 exponent in the denominator. So the derivative, the calculus is not difficult here, but the algebra of exponent rules to rewrite your answer and knowing that roots like square roots and 5th roots can be written as exponents is still required. Okay, and then last thing over here, I would like to rewrite this. So, has anybody got any idea how you think square root of x over x might simplify?
You need to do conjugates.
You can't do conjugates because for conjugates this would need to be like the square root of something plus something or minus something. You need two terms. So I'm asking you, how can I make this look different? I'm not asking calculus.
Multiply by the square root of x over the square root of x.
Okay, if you multiply the top by the square root of x and then the bottom by the square root of x, how does that help? Well, you're not necessarily wrong. What else could you do to this? Okay, you could cancel these out. And then what else could you do to this? Square root is the same as an exponent of what? Okay, and I need this up in the numerator. So x to the 1/2 in the denominator is the same thing as x to the what in the numerator? The negative 1/2. Just change the signs. So you can do that. Or, let me ask a simpler question. What is x to the 5th divided by x to the 4th? Okay, and the reason why it's x is because when you divide things with the same base, it's like you subtract the exponents. 5 minus 4 gives you 1. So personally, that's what I would do here. I would say this is like x to the 1/2 minus x to the first. Or, I'm sorry, minus 1. Dividing things with the same base is like subtracting the exponents. Again, you're used to doing that when it's set up this way. You're not used to doing that without being prompted or pushed in that direction. So I would just subtract the exponents, get to this, and then that's the same that we discovered here. So I'm not saying my way is the better way, but ultimately you've got to make it look in the right format before you even think about doing calculus. Now we can do the power rule. Bring the power down, lower the power by 1, and if you have a negative exponent, it needs to move to the other side of a fraction to become a positive exponent. So again, this is where I was saying that you're going to get sick of me saying this the first couple months, but power rule is not difficult, not hard to learn, not hard to use. That's not what makes calculus difficult. Calculus is difficult because they throw random exponent properties at you. They expect you to remember that roots can be written as fraction, exponents. So if you remember all that, then it's great, and if you don't, then it's just that much more. Okay, and then finally, to finish up our notes here so we can move on to the book assignment.
Can you go back real quick so I can see these? Alright.
Got it? Okay. Okay, a couple other of our book questions are going to refer to horizontal tangent lines. So horizontal tangent lines are a very common thing. So just like horizontal lines have a slope of 0, when we're talking about horizontal tangent lines in calculus, we're talking about when the slope is 0, but that's also the same as when what is 0? Derivative. Derivative means slope. So when you're asked, and we do these 3 questions down here, to determine if and when it has horizontal tangent lines, you will have to find the derivative, know that that's going to happen when the derivative is 0, and then solve the algebra problem with that. But before we actually practice doing that, here's an example problem. Some made-up graph. This graph is supposed to represent the distance you are away from home at a given time. So this is like a distance or position graph. And so, I don't know the units, but it looks like you're pretty far from home. You're getting closer and closer. You're at home. If you're at 0, you move away from home the other direction. But is there any times in here that that you would have horizontal tangent lines? Is there any instances in here where the slope is 0? Yep.
Like at the peaks and valleys.
I'm sorry?
Like at the peaks and valleys.
Okay. Such as x equals what?
X equals 3 and like x equals
Okay.
5.
At x equals 3, we can see at that instant the slope is 0. X equals 5, I also agree with. I think there is probably one more.
Yeah.
Yeah, x equals 1. Now think about this. If this is supposed to be a position graph, if at x equals 1, x equals 3, and x equals 5, x equals 1, 3, and 5, what do you think's happening during those instances?
You're stopped.
You're what?
Stopped. Nobody.
Good, you're stopped. At that instant, you are at rest. If this graph represents something that we are interested in, then when you have horizontal tangent lines, it's probably a point of interest. Why is he stopping during that time? It could be that he's changing directions. It could be just that, I don't know, he's tying his shoe or something. But imagine if this graph represented like the cost of your business. You're going to be way more interested in trying to find this minimum than you are a maximum. You want your costs to be low, not high. But if you were talking about profit, you would care much more about this than this. You would want your profit to be high. It's maxing out when you have a slope of 0 or a horizontal tangent line. So for that reason, horizontal tangent lines just generally are more interesting in the real world. Okay, last thing I want to say about that before we just practice the arithmetic to this. Oh, okay. So y'all said at rest. or stopped. I don't remember what you said. At rest, at rest, at rest. So think about that. What does the rest of the slopes mean? What do all of the slopes really represent for this person? Not the points, but the slopes.
Derivatives?
Okay, it represents derivatives, but what do the derivatives represent in the context of this made-up question?
Quickly he's moving.
Okay, I heard speed. What did you say?
How quickly he's moving.
How quickly he's moving. So tomorrow, that's going to be one of the first applications of derivatives that I can tell you. If you know how something is moving through time, position, then all of these slopes represent how fast he's moving at those instances. So it's not that I really care about slope per se, it's that slope represents his speed. In fact, if you take the derivative of the speed, you get something else. Any guesses what that would be? Close.
Acceleration.
Acceleration. So in calculus, we do lots of position, take the derivative to get velocity, take the derivative to get acceleration. There's also something called a third derivative that we don't typically do in here. We don't do applications of third derivatives, but just so you guys know, if you ever see, like I've seen t-shirts and they'll say like, don't be a third derivative. Third derivative is also known as a jerk, so it's kind of a math joke, but we don't do third derivatives in here, but that's what they're referring to. Okay, so let's actually do this. So we know some idea now of why horizontal tangent lines, we might care about those coming up this semester. But if you were asked to find the horizontal tangent lines of this guy, you would say, okay, the part that you have to know in your head to have a chance at this question is you have to know it's when the derivative is 0. So you'll have to take the derivative using the things we talked about on this handout. And then to finish the question, you've got to use the rest of your algebra knowledge. You're going to have to set it equal to 0, subtract the 1, divide the 3, take the square root of both sides, don't forget plus or minus. And what happens when you try to take the square root of a negative number?
It just reverts to a positive.
It does not just revert to positive.
You get an imaginary.
You get imaginary numbers. And where do imaginary numbers show up on a graph?
They don't.
They don't. So this guy has no horizontal tangent lines. If you want to graph that in your calculator, there's no times that that graph is flat, even for a slight instant. And I just proved that. So again, imaginary numbers don't show up on graphs. Horizontal tangent lines are on the graph. Okay, so same idea for this one. If it said find horizontal tangent lines, you'd have to know this. The calculus would be knowing this notation, knowing the derivative of x is 1, doing the power rule, and the derivative of 4e to the x would be 4e to the x. But the bulk of the question, the bulk of your thought and time and consideration comes from trying to solve this. So sometimes you solve one and imaginary numbers show up. Sometimes you're going to try to solve this. I'm going to switch these.
So x defaults to 1.
No, x is not 1.
But like the previous two questions, when you put it in the form to start, x became 1.
Why? The derivative became 0. I don't see where x became 1. Where is x 1?
So it's like x to the third power plus x.
That's the derivative of this. I did
Why
power
does x become 1?
because the derivative of x is 1.
Okay.
Do the power rule. What's the exponent on x?
1.
Okay, so when I bring it down, it becomes 1. I lowered the power by 1, that becomes 0. And x to the 0 is just 1. So, or you can think of it like this. It is y equals 1x plus nothing. This is like mx plus b, and the slope is 1. Slope is derivative. So, I got you down. Okay, so you get down to something like this, and then you have to remember, well, wait, to solve an exponential equation, I've got to do something like logarithms. And you maybe get an answer of the natural log of -1/4. What's special about this?
It's a value.
Okay, what is the value?
Of the, because it's over 4, right? You can bring that to the x value or something like that.
This is a problem. You can't take the log of 0 and you can't take the log of a negative. So again, that's where like you guys have heard this and I saw a lot of you realize, oh yeah, I knew that. But can you think of that on your own at the end of the question? You can't take the log of 0, you can't take the log of a negative. So this one also would never have a horizontal tangent line. Feel free to graph it and check it out if you don't believe me. So sometimes it might be imaginary stuff, sometimes it could be a logarithm property. I'm not saying that every question is different, but this is what can be challenging to students. Okay, and then last one, we'll try to find the horizontal tangent lines of this guy. So you have to memorize that is where the derivative equals 0. Throughout the book assignment, you will practice taking derivatives so that you can do it quicker like I did. And then to solve this, again, the solving just going to vary. Sometimes it's super easy, sometimes it's a real pain. This question we could subtract the square root of 3 over, divide both sides by -2, and then you are left with something on the unit circle. Sine is square root of 3 over 2 when x is pi over 3 and 2 pi over 3. So my derivative wasn't tough. Memorizing that horizontal tangent lines is when the derivative equals 0 wasn't bad, but if you don't know the unit circle, then you can't finish the question.
Don't you need to make the square root of 3 over 2 negative? Because you divided by -2.
I also subtracted this over,
Oh.
so it was a negative divided by negative. Okay, any quick immediate questions that jump out at you? Obviously, you're going to get better at these as you practice them, but anything you want cleared up while we're here?
Wait, no.
Okay, then on your blank piece of paper I asked you to get out today, or this morning, if you go ahead and copy down the full assignment 17. It looks like a pretty long book assignment, but when I did this with my 3rd period class, I think I answered the first 10 questions in about 2 minutes. Like a lot of the first ones are very, very quick. So go ahead, copy the assignment down. The paper that I told you not to write on, the book questions, that's where they are. If you flip, I also printed out the odd solutions. So like in a textbook, you would normally need to go to the back to see the odd solutions. That's your last copy here. So these book pages are printed for you. I did also copy the odd answers on the back. So that you can check those. But copy the assignment down, start the first few questions, and I'll give you a little bit of a head start, and then we will go over as much of this as we have class time for. But I really do think that you can either finish this in class or be very, very close to finished in class. We do have about 45 minutes.
Multiples of 3.
Yeah, I think it is multiples of 3. There might be one missing though.
Can I leave it like 10? Because I need to get somewhere early for NHS.
No,
I can.
not without a note or something.
Okay.
We're not allowed to let people leave early. Now, of course, you have your notes out, so you could look at your notes to help you with question 3. You could use your notes to help you with question 6, but try to use your notes less and less. These couple things that I asked you to memorize, couple derivatives I asked you to memorize, and the power rule, we'll be using those a lot tomorrow. So the more of that that you can keep up with in your head, the smoother tomorrow will go. So try to wing yourself off your notes as you move along. I would like to go over one question with you, which would be question 27, just because usually some students have questions about the directions. But even before question 27, I'll just go ahead and say all the answers to the other questions, partly just to highlight to you that there's really not a lot of work to be done with these. So question 3, I know you had the odd answers in the back, so you should have already checked these, but 3 was 0 because the derivative of the constant is 0. Question 6 would be 12x to the 11th, because that's how you use power rule. Number 9, you'd have to rewrite first, but your derivative would be 1/5 with x to the 4/5 in the denominator. That's just power rule. 12 would be 6, either from derivatives or just see that it's slope. Mx plus b, the slope is 6, so the derivative is 6. Those mean the same thing. 15 would be the power rule twice, 2x plus 12x squared. 18, power rule again twice, 6x squared plus 12x, and then plus 0. 21, power rule, and then one you have to memorize, 2x plus 1/2 sine x. And 24. 3/4 e to the x would be 3/4 e to the x, because e to the x is one that stays the same. And then the derivative of 2 cosine x would be -2 cosine x. So I just did 1, 2, 3, 4, 5, 6, 7, 8, 9. Oh, 1, 2, 3, 4, 5, 6, 7, 8 questions. So just to emphasize that once you have those memorized and once you get comfortable with the power rule, those don't take a long time. But I did want to talk about question 27, again, just because the directions, you may not know what it's asking for, but it's the same thing we did in your notes. 27 gives you a function, 6 over 5x to the third, and basically it wants the derivative simplified. But this is not in derivative format, or this is not in a format that you can do power rule for, and that's pretty much all you know right now. So what you need to do is you have to rewrite this. This is why there's a column for rewrite. You could do 5 to the third, x to the third. This is still not in the correct way to do power rule. You have to bring this up. The x can't be in the denominator to use power rule. So now, this is kind of a messy number, but it's just a number. So here's my rewrite. Now that it has been rewritten, now it should be simple enough to do the derivative or to differentiate by hand. Could bring the power down, lower the power by 1, and we wouldn't leave that as a final answer because we can simplify this, which is the last little column. Negative exponent in the numerator is the same thing as a positive exponent in the denominator. So they're trying to help you by asking you to list out the 3 steps. But you can't just take the power rule whenever you feel like it. It's got to be written in a certain way. You can't have x's in the denominator. So I think that will clear up 27. Okay, does anybody have anything you'd like to ask about question 27 or any of the ones before it? Since I just
18.
Okay. What about it?
So I got 6x to the second power plus 12x minus 1.
Minus 1's a constant.
Yep.
What's the derivative of the constant?
0.
Okay, so the first 2 things you said were right, but not a minus 1. The last part would be 0. 6x squared plus 12x is all you need. Because the minus 1 changes the value of y, but it doesn't change the rate that y moves. So that's why it doesn't impact the derivative. Let me give you a little bit more time to work before I ask for other questions. Push.
So,
You can't take the derivative until x is out of the denominator. And then negative 4/3. So the rewrite, I would actually move this up right here, call it x to the positive. Oh, that's what the 1/3. Then you can do it. That one, you're gonna have to. Okay. That's very clever. No, this is fine. We've distributed. Right here though, you can't combine these two together. This is like 2 times x, and this is like 1 over. Oh, you did derivative. Okay, see, I can't tell when you went from function to derivative, so that's where. The derivative of this would be 0. The derivative of 2x is 2. So what you did is fine, the approach you did. The other thing you could have done on this one is just split apart your fraction. You could have put 2x to the 4th over x to the 3rd, and then minus x over x to the 3rd. And then simplify both fractions. Okay. Well, they want to know the derivative after. So you need to find the derivative first. Okay, 8x to the 3rd. Okay. And then they want to know what's the derivative at this point. So plug 1 into that, and then you know the slope of that.
So you just plug in the next one.
You would need the point if the direction said write the equation of the tangent line, but then you would need the x and the y. So
So, started by moving the 3 up to here, so 4 to the third divided by x.
4x to the third. Okay, now the x goes with it, because it's x to the negative 3, so that stays together. So when you move that up, it becomes x to the positive 3.
Okay.
So 4x to the third would be your rewrite.
I move that down to go to 12 x to the second power.
Uh-huh.
And would that be it?
That's it. You've already got positive. Yeah, you've already got positive exponents. So now your x, again, your x needs to be up in the numerator. It's not, the square is stuck. The cube is stuck to the x. You can't just move the exponent up by itself.
So our with
This would be 4x to the third. When you move this up, the x goes with it. Okay. And then the derivative, yeah. Now it looks good. Okay, let me offer to help out with a question or two on the board. Is there any that you've tried, either your answer's not matching up with the back, or any that you're not sure how to start, or anything I can help with? Okay, Ryan? Question 39. So as they get you to move along here, and we're getting near the second half of the assignment, I think what they're trying to get you to see is that when it looks like this is in the format that's ready to go for power rule. Bring the power down, lower the power by 1. But this is not the right format. Your variable can't be in the denominator to do the power rule. So for this, you need to move this up to the numerator. So exponent of positive 3 in the denominator is the same thing as an exponent of negative 3 in the numerator. And then now, this is in the right format for power rule. Now you can bring the power down, lower the power by 1, and your answer is certainly not going to look like the back of the textbook, because you shouldn't leave negative exponents. Move this t to the negative 4th. Oops. Move the t to the negative 4th back to the denominator and make it t to the positive 4th. That's what they should have done. Yeah, that's what they've
the
done.
x moved up as the exponent or not? On number 30. Would it be 4x to the third power?
Mm-hmm.
Okay, I got it.
That's the rewrite part. Okay, did that answer your question, Ryan? Okay. Again, you just basically have to train yourself that it's got to look like this to do power rule. If it doesn't look like that, you got to make it look different, either by splitting apart your fraction or rewriting your exponents or whatever. Just depends on the question.
The problems we do is multiples of 3 up to which number?
I don't know. I'll put it back up later. I'd already asked you to copy that down. So. Okay. You guys got another question or two I can help with?
You did 57.
57?
Yeah.
57. Determine the points, if any, that the graph has a horizontal tangent line. Okay, so when I read the directions there, I know horizontal tangent lines are when the slope is 0 or the derivative is 0, same thing. So for 57, you're going to have to take the function, find his derivative, and then figure out where his derivative equals 0. And this would equal 0 at 0, 1, and negative 1. Does that make sense? Okay, but they did say points. So those are the x values that your derivative is 0, which is where you get horizontal tangent lines. But technically, if they want points, make sure that if you're trying to find points, you're using the function, not the derivative. Derivative gives you slope, the function gives you points. So if you plug 0 into this, 0, 3 should be a point. You plug 1 into it, I think you should get 2. And if you plug -1 in, I think you get 2 again. So, points come from the function, slopes come from the derivative. Okay, y'all still have about 22 minutes, so I'm going to set one more timer for about 10, 12 minutes here. And I'll take one more round of questions. And in the last 10 minutes, I'll make sure you know where you need to be before tomorrow. Again, like I saw you guys last time, I talked about, B-days. Sometimes you guys are lucky and get extra time, just like you got a little extra time to study before your quiz. But then sometimes it's back-to-back B-days, and I don't have control over that. So luckily, you should have very, very, very little homework, if any. But you might, depending on how far you get. Yeah. Mm-hmm. You could.
I guess what I rewrite it as.
You could.
Okay.
And then you could distribute that.
Okay.
That's one way to do it.
Is there an easier way to do that?
I don't know. If that's what you see, then that might be the easiest. What I would probably do is split the fraction up. You can split apart numerators, so I would put this over this, and then minus this over this. Then I would simplify this fraction, simplify that fraction, and then I would do power rule. But it's give or take. I mean, I don't know that that's easier. It's just what I see.
Thank you.
Okay, so find the derivative first. Okay, and then they want to know what is the derivative at that point. So here's this 33. So they want you to plug this in, but you really only care about the x value. So plug 1 in for x. So you know at that instant, the slope or the instantaneous rate of change of that function is a. Okay. 42? You're the, somebody did that now, so let me talk about that. Okay, I've gotten a question about 42 a couple times already, so let me talk about it on the board. There's actually a couple ways you can approach this. I'm going to tell you what I think is probably better for you long term, but I will also share with you what some other people were doing, and it was perfectly fine also. Okay, so I saw at least 2 people do this already this morning. They brought this up, so that makes this like 2x to the 4th minus x, and when you bring this up, this becomes x to the negative 3. This is not in the right format for power rule, so you can't get to calculus yet, but then you could distribute this. Remember, when you multiply things with the same base, you add the exponents. So this is like 2x minus x to the negative 2. And then it looks like it's ready to go for derivative. The derivative of 2x would be 2. The derivative of this, I don't know. I'd have to move it back. No, I wouldn't. Sorry, ignore that. Bring the power down, lower the power by 1, and then to make it be simplified, they're going to expect you to bring this back down. So there's nothing wrong with that. I don't think this is going to be as useful as what I'm about to show you, though. I just think that this is kind of limited case. The other thing you can do is you can use fraction properties. You can always split up numerators. You can't split apart denominators, but you can split apart numerators. So I can put 2x to the fourth over x to the third, as long as I also put x over x to the third. And then this fraction simplifies to just be 2x. This fraction simplifies to be x to the negative 2. And then you can see I'm working the same question that I did over here. So if you really think this is easier, again, there's nothing wrong with it. But that idea of splitting apart your fraction right here into multiple terms, splitting apart your numerator, I think is going to be a better strategy for you moving forward. Just out of curiosity, had anybody already heard of the power rule before today? This one? Did you study that on your own, or did it come up in some other class you had?
It's probably we've already done all of this. Or, well, I did at my old school.
Oh, it's your old school, okay. Did y'all do limits in pre-cal too?
Barely.
We don't do any derivatives in our pre-cal classes, so any that you did is a little bit of a heads up. Do you remember if you did product rule, quotient rule? You did?
Yes.
Okay.
I
That's
don't
a big
remember
part of the
much
tomorrow.
it, though.
Huh?
I don't remember too much of that.
Well, still, you still got a head start for everybody. Can't be finished yet. I'm thinking. How'd you check your answers to 53? Oh wait, you didn't do 53. 54.
Me and Joe's talked it over.
You trust him?
Yeah,
So you could both be wrong.
you could. But look at my notes and work it through these.
Okay, I do need to say one more thing to you guys real quick here. So actually back up here in the questions 30s as well. If you look at question 33, it talks about find the slope at the given point. So you should have taken the derivative, plugged in x equals 1. But then it says something about use the derivative feature of a graphing utility. So I need y'all to be aware that this is a thing, because even though none of these questions need a calculator, your AP exam, half of the points come from calculator sections, half the points come from no calculator sections. Sometimes they're going to give you derivatives that you cannot do by hand. There's only a couple ways to do derivatives by hand. There's power rule. There's the ones we memorize, which you guys already have a little bit of a grasp on those two things. We have to do product rule, power rule, product rule, quotient rule, which I'll show you tomorrow. And then the only other one you have to do by hand is something called chain rule. So there's not a ton that you have to do by hand. So when on the AP exam they give you some weird function that is impossible to take the derivative by hand, they're expecting you to do it in the calculator. So in question 33, they're wanting you to check your answer. So if you hit second window, you should have some options here. We will use this option 3 and 4 a lot this year. 4 is for integration, which is going to be most of next semester, but option 3 is derivative. So you have to define what you're taking the variable of, or you have to define the variable that you're taking the derivative of. So I put an x here. And then number 33 was 2x to the 4th minus 3. And you wanted to know the derivative at x equals what? 1. So your calculator is not programmed to do derivatives for you, but your calculator is programmed to do derivatives at a specific value for you. And you need to be aware that it's there. Practice using it sometimes so that someday when you get a test for me and it's part calculator and there's some derivative you don't know how to do by hand, even if you do know how to do it by hand, why not just let the calculator do it? As long as it's a derivative at a value, it can do it for you. Now, it's got a little bit of a rounding error sometimes. The way it calculates this can be a little bit off. So, question 33, did you get an answer of 8?
Yeah.
Okay. So, I just need you to know that your calculator can do that. Practice finding it a couple times so that when you need it, you know it's there.
What was that second?
I do alpha window. I know it's in a couple other places too, but alpha window has this extra menu. There's a bunch of extra stuff in it. Absolute value is nice. Log base, where you can tell it what log base you want. Determine the points, horizontal tangent. So this is going to be variable derivative. There's no plus 3. The derivative of the constant is 0. So that goes away. And then horizontal tangent lines is when the derivative is 0. So you need to set that equal to 0 to solve that.
Yeah.
0, 1, and negative 1 or something. Okay. Oh, you already went. You need to go get this for us.
Yeah, I tried to do that, but it's such a
You need to make it your quiz too, so I think I've got you set up for
That's good. And I have
papers.
the ones that do, right?
I haven't turned in 3 the day of this.
I mean, I had it.
Okay, just hang on to them until you make up your quiz. Give them to me when you make it. No.
What's that?
Is this too over for?
Yeah.
You can just reduce that to the half.
Because then you would
And then this is like x to the 3 halves. You can move it up to the numerator. X to the negative 3 halves. But you cannot do power rule with this part and then do power rule with that part so you try to combine them. It doesn't work.
So
Unless it's terms. If they're being added or subtracted, it's fine. That'll make sense. Again, you don't need to get up separately for this, but I do need these book printouts back. I need these for my other classes. Again, I've got tons of books to check out. If you want to check out a hard copy, I put the digital copy on Google Classroom if you wanted, and on our class website, I try to put individual uploads of just a couple pages you need. So I need these back. So at the end of class, if you just want to put them back on this pile over here where you got them, they'll be here for my next class. So I would, and I will try to keep doing that, but a lot of it depends on me getting them back. If 10 of y'all keep them, then I don't have a class set, and then that doesn't work anymore. Hold on a minute. Okay, so we are down to about 8 minutes. So again, I will see you again in the morning. If you did not finish, you should be pretty close to finished. For homework, you need to finish up this book assignment. I'm going to take it up first thing tomorrow. there's a good chance you might need help with a question or two on here. But on our class website, I have every one of these questions pre-worked out as separate individual videos. So if there's any of them you're not getting the right answer for, go to our class website, scroll down to this assignment, number 17, and if it's question number 60 you need help with, just click 60. It'll pull up a YouTube video of me going over that question, and it's probably just a 2 or 3 minute video. It's just that one question. So that way you're going to get the help that you need, and we can all be at the same place and ready to go for class tomorrow. So make sure that you add that to your homework list. Okay, and if you're interested for the daily puzzle, have I shown this one before? Y'all have not seen this one before? Okay, so just slightly different. Not a real puzzle, but that's what I got to show for you today.
Were you supposed to decode it?
Right.
Supposed to read it.
So that's really cool.
Have y'all seen those before? I feel like you should probably talk about that in psych. If you have psych, about why your brain is able to do that.
I think I've been here for 5 minutes.
Okay. Is there a question? Oh, you want me to? Yes, you are.
I figured it out. I was just gonna do like a C8 on it, but I learned to be
Parsons in here.
Do you know what it is?
How's that got passed?
We tweaked it a little bit where it's not, you know, like that.
As soon as you piece together what like the letters is, it's like automatic.
Yeah. But that's what's interesting about it is your brain should struggle a lot, but it doesn't struggle that much.
Yeah, once you get past like the second, third line, you start reading it faster. This message serves to prove how our minds can do amazing things, impressive things. In the beginning, it was hard, but now, on this line, your mind is reading it automatically without even thinking about it. Be proud, only certain people can do this.
Yep. Oh, thank you. How did you know it was my birthday? Who? Miss, I don't know why Miss Buckley told everybody this year.
Happy birthday, though.
Thank you. How old do y'all think I am?
That's a trap.
You know,
What do you mean it's a trap? I don't care. You're not going to offend me. I don't care.
I was gonna say like 39. They said 38.
46.
Okay, I might get offended. I'm 41.
Okay, so
You were very
I was
close.
thinking late 30s, early 40s.
That's a good guess.
So how many years have you not missed a day?
Do you know what year this vase was built?
No.
Me neither. That was the last year I took a sick day. No, it wouldn't be that long. It'd be 2014. 2015. The end of 2015. Or, no, I'm sorry, 2015. So, I've almost made it 10 years. When was the last time you missed a day? Last week?
No, I didn't say that last week. But
When you felt bad from drinking all that cream tea?
I actually feel great. I feel sharper. It improves cognitive abilities. But I think it was like March, February.
Of this year?
Oh yeah, this year. Yeah. Got that season.
Maybe you should be taking health advice from me, because
Yeah. What do you prescribe for seasonal allergies?
well, I can't help you with allergies. But the best thing you can do is stay away from everybody. Well, y'all are over there away from me, so y'all aren't sneezing on me.
That's what gets me.
Eat good food, good clean food. No fast food.
Got some beef and potatoes for lunch.
Get lots of rest.
8 hours.
Wear sunscreen. Eat spicy foods.
What is spicy food?
I don't know. I watched this video about how to live longer, and there's like certain things that they've shown that like can help you live longer. Plenty of sleep, sunscreen every day, spicy foods,
Every
workout. Huh?
Every day.
What every day? Sunscreen.
Sunscreen?
Yeah.
You wear sunscreen every day?
On my face, yeah. Skin cancer is one of the leading causes of death. Putting sunscreen on your face every day is, you just pretty much eliminate that.
I couldn't tell you when the last time I put on any sunscreen.
Well, I didn't either when I was your age,
You a
but
big AeroPress?
huh?
You a big AeroPress guy?
AeroPress, yeah.
I prefer the French press myself.
Okay.
You gotta grind it like when you make it. It makes a big difference. Get
Yeah.
you a hand grinder.
A hand grinder?
Get your morning workout. Get one of those electric.
I grind at home.
Yeah,
but then it's
and then all the tannins come out, and you lose the depth and the flavor and the body of it.
well, I also buy pretty cheap coffee, so I'm not a coffee snob. I'm
You
somewhere
gotta
in the
get
middle.